But page 165 and 167, you're actually going to tear these 2 pages out of your book. Notice they are single-sided because the plan always was to tear those pages out. And you are going to then cut your chromosomes out. They are individual chromatids like this. You don't have to cut them along the line. You can just cut them in strips like this. And then what you're going to do is you're going to it's easiest if you take a piece of tape and you put the 2 identical sister chromatids together. So I have just put my big A, big B, big D, big E, big F, big G, big H together. So once you do that, you are going to end up with 4 chromosomes. All of these are copied chromosomes, the ones that are ready to go through cell division because we've done interphase and we have copied those chromosomes. So we've got our 4 chromosomes here. What you're going to do next is we're going to start going through meiosis. Meiosis without a T. Meiosis is the type of cell division that's going to give us our sex cells, our sperm and egg cells. So just like mitosis with a T, meiosis starts where all of the chromosomes are together in interphase, where we cannot see individual chromosomes. And then we're going to begin cell division. Similarly to mitosis, prophase is the first phase of meiosis. But meiosis has 2 divisions. So we need to talk about prophase 1 versus prophase 2. So the first time we're doing this is prophase 1. So in prophase 1, we can see our individual chromosomes. They're all separated. The nuclear membrane is going to disappear. And one additional thing is going to happen in prophase 1, and that is that the homologous chromosomes are going to match up. So homologous chromosomes are those chromosomes that are the same. They're going to have the same kind of information on them. So I already mentioned that I have this chromosome over here that's my capital A, B, D, E, F, G, and H. I also have another chromosome here that's little a, b, d, e, f, g, and h. So this is the homologous chromosome pair. So they are going to match up. Okay? And then I've got J, K, L, M, N, P, Q, and R chromosomes, and they are going to match up. So these homologous chromosomes are going to come together, and when they come together, they're going to form a tetrad. And it's called a tetrad because it's a close bundling of 4 chromatids. 1, 2, 3, 4. Tetra meaning 4, like a tetrahedral, or the game Tetris. Tetris, the game, has 4 blocks in every shape. That's why it's called Tetris. You never knew that. So the tetrads are going to come together, and normally in meiosis, this would be a time of crossing over. But in this activity, we're going to see what happens if crossing over does not happen first. So if you're looking at your directions in your book, which is on the next page, which is page 169. The first time we're doing this, we are not doing crossing over. So we've just got the tetrads together. So now we're going to go through the rest of meiosis. So we've got prophase 1 is done. After prophase 1 comes metaphase 1. The chromosomes are going to line up in the middle. After that comes anaphase 1. So in anaphase 1, the 2 chromosomes are going to split apart, kind of like that. And we'll get to telophase 1 and cytokinesis 1. and our cell is going to split. So I'm going to just kind of put that pencil there to show that we now have 2 cells. Now, each of these cells is going to have to go through meiosis again because meiosis has 2 divisions. So we've done 1 division, but we're not done with meiosis. Now we have to do this again. So, again, we'll start off with prophase, but this time it's prophase 2, so we can see our individual chromosomes, but we're not going to have any pairing up of tetrads because if you notice, we have different kinds of chromosomes now in our cells. We've got an A through H chromosome, we've got a J through R chromosome in each of our cells. So this second division is a little bit more like mitosis because prophase 2, just the chromosomes become visible, the nuclear membrane disappears. Now we're going to do metaphase. I'm going to try to squeeze these in. I'm going to kind of make my metaphase kind of on top of each other a little bit just because I don't have very much room to get this video all in one field where you can see it. Once metaphase happens, then we're going to have anaphase, and this time our sister chromatids split. Our centromeres split, and 1 chromatid goes in each direction. All right, so 1 chromatid goes in each direction with my anaphase. And after anaphase comes telophase. And so then we're going to split these cells. I might need some extra, I'm going to add some extra splits to my cells so that hopefully you can see that we've now got 4 cells. And each cell has 2 chromosomes in it. So meiosis gives us 4 cells at the end of division, and we have half the number of chromosomes that we started with. If you remember, we started with 4 chromosomes. Now we have 2 chromosomes. And if you look carefully at your chromosomes, you can see that we have 1 of each kind of chromosome. So I've got an A through H chromosome, and I've got a J through R chromosome in each one of my cells. This means that we have 1 of each kind of chromosome, and that is a haploid cell. Okay, so what you're going to do now in your crossing over activity is you're going to write down what are all of the genotypes of each of these cells. So we've got 4 cells. You've got 4 boxes to record your information. On your page in your book, the boxes are going across, but you've got 4 separate boxes. And you're just going to write down, what do you have? So I've got little a, little b, little d, little e, little f, little g, and little h. And then little j, k, l, m, n, p, q, and r in one cell. Do that for each of your cells. Yours might be a little bit different than mine, but see what you've got.